Hello, BNS 380. We're going to get into hypovolemic thirst in just a moment. Sorry, this is later than I intended to do this, but I just took a nap and it was glorious. I've also showered and put on real clothes today, so we are winning for the day. I got big plans tonight, doing Zoom trivia with some friends, so got to get prepared for that. Hang on, let me get my PowerPoint up. Oh my gosh. All right, here we go. All right. Boom, here we go. Okay, so on the last video, I have all these, like, the last time I did this lecture, if this tells you how far behind we are, I did this lecture around Halloween last time. That's why there's Halloween things on here. So on the last video, I was talking about osmotic thirst. So osmotic thirst is whenever you have an increase in osmolality in the interstitial fluid. This is an increase in sodium, usually glucose also. So you have an increase in these solutes in the interstitial fluid, which is a component of the extracellular fluid. And this causes the, whenever you have this happen, this pulls water out of the cells, so you have cellular dehydration. Cellular dehydration is picked up by the osmoreceptors, which are found in the subfornical organ, the area postrema, and the hypothalamus. These are areas of the brain that are not covered by the blood-brain barrier. So the subfornical organ in particular, which is by the third ventricle, will signal to the hypothalamus to release vasopressin from the supraoptic nucleus and the paraventricular nucleus of the hypothalamus, which of course is released from the posterior pituitary directly into the bloodstream. And once ADH, antidiuretic hormone, is released, then its target cells are found in the kidneys, and it will go to these kidneys and it will tell them to, especially in the nephrons, and it'll say, we got cellular dehydration, we need to start conserving water. So that'll signal to the kidneys to start holding back water. So it will hold in the water, and therefore you will have a higher concentration of solutes in your urine, so your urine will appear more yellow. And one thing that it also does is it constricts blood vessels, because this is also a way of restricting water and conserving water in the body. So you'll have an increase in blood pressure, and then you will also be getting signals from your hypothalamus to drink. You will be feeling thirsty at that point. Cheers. So that's osmotic thirst. So today, again, it was near Halloween, but this picture actually works out great because this is describing what is known as hypovolemic thirst. When you have osmotic thirst, this is cellular dehydration. So this is whenever water is being pulled out of your cells. But hypovolemic thirst, on the other hand, is a reduction in blood volume. So this happens for lots of reasons. Maybe you're bleeding, maybe you've just done a really hard workout and you've really sweated out. The other thing that could happen here is if you have a really heavy menstrual cycle, that could trigger it too. So this is just an overall reduction in blood volume. So you need to not only replace water like you do in osmotic thirst, you need to replace water, but not solutes. In hypovolemic thirst, you need to replace both water and solutes. So because you have this low blood volume, what you'll have is low blood pressure. And if this continues and you lose a lot of blood, then your kidneys are going to be unable to function. So instead of osmoreceptors here, what we have that's important is baroreceptors. And these are located on the actual blood vessels. So these are also stretch receptors. We're going to talk about, we heard about stretch receptors when we talked about parenting, which I guess I didn't record that. But in parenting, there's the stretch receptors in the vagina that causes the release of oxytocin. So here we also have stretch receptors on the blood vessels, and these are baroreceptors. And so whenever blood volume drops, obviously you have a reduction in blood volume. This is going to cause the blood vessels to trigger, and they're going to notice this, and so this is going to signal back to the brain, and the first thing that's going to happen is ADH is also going to be released in this situation. ADH is going to be released. It's going to tell the kidneys that we need to start holding back water, and it's going to tell the brain that it's thirsty, and it's going to do all of these things. It's going to also be a vasoconstrictor. So that's the first thing that happens. So in both hypovolemic and osmotic thirst, antidiuretic hormone is released. Okay, so one thing I wanted to note about ADH is I wanted to talk briefly about the Brattleboro rats. These come from Brattleboro, Vermont. My ex was up last year. He was doing a motorcycle trip, and he was going through Vermont, and he stayed at Brattleboro, and he sent me a picture where he posted something on Facebook that said he was in Brattleboro, and I was like, Brattleboro, the rats. He was like, what are you talking about? So I had to explain. Anyway, see, these are rats that do not produce antidiuretic hormone. They were kind of found by mistake. So these rats, they, because they do not produce antidiuretic hormone, their kidneys never get the signal to hold back water. So due to this, their kidneys are constantly dumping water. So they will drink and urinate constantly. Like, that's all they do. And this causes a condition known as diabetes insipidus. I'm not sure if we talked about this yet in class. I feel like maybe we did. But this is different than regular diabetes that we'll talk about when we talk about energy balance in the next lecture. But this is whenever you have either deficient antidiuretic hormone or low levels of antidiuretic hormones. So, or your kidneys are unresponsive to ADH, which if either of these happen, then your kidneys will be releasing a lot more water than normal, and you will be a lot more thirsty than normal. Okay, so now let's talk about hypovolemic thirst. So the first thing that's going on is you're having this reduction in blood volume, and so these baroreceptors are being triggered, and it's telling the brain that we need to, first of all, drink some water. So ADH is being released, and it is going to the kidneys, telling the kidneys to hold back on water. The next thing that's going to happen is you're going to have the creation of angiotensin. And so what we have here is this is the pathway to create angiotensin, which is a hormone coming from the blood. So first we have angiotensinogen, and this is always available in the blood. This is produced from the liver. That's where this comes from. And then in times of hypovolemic thirst, when you have a reduction in blood volume, the baroreceptors will tell the kidneys to start producing renin. And once renin is around, then this causes angiotensinogen to be converted. So renin is also a hormone being released from the kidneys. It's going to go into the bloodstream, and it's going to cause angiotensinogen to convert into angiotensin 1. And then angiotensin 1 doesn't really have an effect. It has to be converted into angiotensin 2 for it to really have an effect. So whenever you hear angiotensin, it is really talking about angiotensin 2. So you have this converting enzyme that is actually from the lungs, and this is ACE. That's the enzyme. It's a long word, but if you've heard of ACE inhibitors for like blood pressure medications, that's what they're attacking. They're attacking and inhibiting this enzyme. Because if you inhibit this enzyme, then angiotensin 1 is not converted into angiotensin 2. And angiotensin 2 and angiotensin 3 are the ones that have the effect on the body. So by eliminating that enzyme ACE, then so that's one thing that blood pressure meds attack is. So if you've heard of ACE inhibitors, that's what they're inhibiting. Okay, so a couple things that angiotensin does is angiotensin tells the adrenal cortex to start releasing aldosterone. We've talked about aldosterone before. This is a steroid hormone, so it can cross in and out of your cell membranes. So it is released, remember, it comes from the zona glomerulosa from the adrenal cortex, and it's going to be released because of this angiotensin 2 and 3. And it's also released in response to ACTH from the anterior pituitary. And so this is a mineralocorticoid. And one thing that it does is it causes the reabsorption of sodium. So again, we have a loss of blood volume, we need solutes, and we need water. So ADH is causing you to drink, feel thirsty. Aldosterone is going to cause sodium to be reabsorbed. So this is also going to the kidneys and telling the kidneys to hold back sodium. So one thing that aldosterone does is you guys remember the sodium potassium pumps. So it tends to work to reverse these on cell membranes. So these are found on things other than neurons, but it's going to cause this reverse so that then your cells are going to bring in more sodium so that you have more of this, and it's going to cause it to dump potassium out. So it's going to reverse this concentration gradient that's going on. So it does tend to reverse the sodium potassium pumps against this gradient. So now you're going to bring in more sodium and let out more potassium because we need more sodium. And whenever you do this, whenever you're bringing in more sodium, it's also going to cause water to come into the cells as well. So you're increasing that volume by doing this. Aldosterone also will cause vasoconstriction. So both aldosterone and ADH are causing vasoconstriction. So both of these chemicals, both of these hormones can cause high blood pressure, particularly aldosterone. It's important too that aldosterone is released in times of stress as well. So the adrenal cortex, when it is stimulated to release cortisol, aldosterone tends to be released with that as well. Okay, so sodium balance is really important. It's really important to maintain this appropriate amount of sodium. If we have too much sodium in our bodies, then we have way too much. So that will cause cellular dehydration, and if we're not drinking enough, then it will cause the signal of hypovolemic thirst in the body. So the body does store sodium, keeps it in the interstitial fluid, and so this is important to maintain the sodium balance. If we have too much or too little, then this can interfere with our neural functioning. So one thing to think about, if you think about your own diet, if you are eating a lot of meat, which carnivores do, some of you might consume a lot more meat than vegetables. So what's happening is you're eating that red meat. That meat has a high content of sodium in it. So therefore, the more sodium you bring in, your body is going to excrete more sodium. Your kidneys are going to release more of that sodium. But on the flip side, if you eat mostly plants, then your body will conserve sodium more readily and will release a lot more potassium. So there's always this balance between these two electrolytes. Okay, so a note on sex hormones. Estrogen, estradiol, E2 does increase your blood volume, and progesterone decreases your blood volume. So this will happen throughout the menstrual cycle, where if estrogen is high, blood volume increases. So therefore, so this does shift the set point. So when estrogen is high, your blood volume, the set point increases. So you're more likely to experience thirst. You're more likely to experience osmotic thirst in particular, and hypovolemic thirst when estrogen is high. So your body is more sensitive to that. And then progesterone is going to decrease your blood volume. So again, these two hormones change the set point of your blood volume and what's acceptable and what's not. So one thing to think about is when you have higher estrogen, you're more thirsty. So you're more likely to drink, and you experience, you will seek out water and other things to drink more readily. So you can think about this, right? Because if you have more estrogen, usually estrogen is higher right before ovulation. And so you're probably seeking out a sexual encounter since it's time to reproduce. So you guys have heard of being thirsty, right? So you can think about that whenever you think about estrogen. So estrogen will make you more thirsty, will have you seek out water more readily because it increases your blood volume. It also makes your antidiuretic hormone more sensitive. Okay, so that's hypovolemic thirst. Thank you as always for watching this video. And yeah, so we have one more thing to talk about, and then we're done with homeostasis, and we can move on to stress. So I hope to complete both of those by the end of the semester. Thank you.